You ever walk out of an all-you-can-eat buffet and think, God, I'm full of energy right now? No, you don't think that. You usually put your head down at this point and want to go to sleep. And people usually think of this as a really bad thing, this food coma effect. But I'd like to challenge this notion today by saying, what if it were a really good thing happening at the wrong time? What if we can control when it happened and use it? There are 40 million Americans whose lives are deteriorating from sleep disorders. People that never sleep but never really feel awake. What if we could help them? A number of human studies in the 90s tried to observe this effect but ultimately failed. And I think it's just because they didn't have enough humans in the study. And a way that we typically get around this is by using something called a model system. So a simpler animal that is very easy to work with but conserves the behavior that you're interested in. So 10 years later, it was discovered that fruit flies, a very simple organism, conserved all the fundamental features of sleep that humans have. So we took advantage of this, and we designed a machine vision-based system that allowed us to tell exactly when flies were sleeping and when they were eating. And using this, we collected tens of thousands of events and found that not only did flies sleep more after eating, but this behavior grew with larger meals. And just like that, some idea of the food coma became something concrete that we could study. So we did just that. We started tinkering with the diets, and we found that while sugar had no effect, protein, salt, and volume all seemed to drive the behavior upwards. The next question is, well, how does food in our stomach translate to sleep in our head? And people usually think that blood drains out of the brain and goes to the stomach for digestion, but another group of people think there are neurons that detect the food in our stomach and actually send information to the sleep center in our brain. So to test the second idea, we went into the fly brain and began turning off neurons one by one, looking for a defect in the behavior. And we were astonished to find that not just one neuron controlled the behavior, but many. Some that responded to volume, some to protein, and even some to the time of day. And if we reached in with genetic tools and turned these neurons on, we could control exactly when and how much a fly would sleep. Now, I'm not delusional. I know these are fruit flies, not humans. Some of you are looking at me like I'm crazy. But what this study tells us is that this behavior is real. It is flexible, and we can control it. So if we can take these findings and somehow translate them into mammals or humans, maybe we can help those who have lost sleep from sleep disorders to finally get some rest. Thank you.